All right, the purpose of our video here is going to be to size our motor overloads. This is based on Electrical Training Alliance Lesson 8, Motors 2, Lesson 8. If you're following along, I'm actually going to be doing questions 1, 2, 3, 4, and 8. Overloads is going to be by far the easiest thing we're going to, well, conductors might be easier. If you guys remember correctly, we went to part 2 here in Article 430, Motor Circuit Conductors. 430.22, we multiplied our conductor ampacity based on the table by 125%. This one here is going to be actually a little more challenging, but now instead of going to 430.248 for a single phase motor and 430.250 for a three phase motor to get our ampacity, our motor full load current, we're going to be allowed to just use nameplate values for our overloads. And then there's only a couple of other little caveats, and one of them, the primary one, is going to be if starting current's a problem or not. So what we're going to do is we are going to find where our overload calculations are found, and we can see that that's right here in part 3 that says motor and branch circuit overload protection. So we are going to go to part 3. And actually, in part 3, I actually skipped to the table, but in part 3, and this is where we're going to spend most of our time, where it says more than 1 horsepower. Our fractional horsepower motors, we don't really deal with overloads all that much, thermal overloads. So most of our calculations aren't going to fall into that realm. They're going to fall into the more than 1 horsepower. So 430.32A. 1 is going to be where we're going to spend most of our time on this. And that states that a separate overload device is responsive to motor current. This device, blah, blah. So basically, nutshell, we're using our nameplate amps, and it actually says it right here, trip or shall be rated at no more than the following percent of the motor nameplate full load current. So here's one of the things we have to pay attention to. And in this case, these ones here, starting current is not a problem. This is our standard table where starting current is not a problem. So we're going to take, if we have a motor with a marked service factor of 1.15 or greater, that means that I can load this thing to 115% or greater and not cause permanent damage, not permanently, but I can do that and it won't permanently damage my motor. Or I have a temperature rise of 40 degrees Celsius or less. If I have either one of those two conditions listed, and the other, if I have both conditions listed, then they both have to fall onto those parameters. So if I have a service factor of 1.3 and I've got a motor temperature rise of 30 degrees Celsius, I use the 125% because they both match. If I'm only given one parameter, if I'm only given a service factor of 1.3, but they don't say anything about my temperature rise, I can use 125%. If they tell me that I've only got a 30-degree temperature rise and they don't tell me anything about service factor, I can use 125%. But if they tell me I've got a service factor of 1.3, but a temperature rise of 50, my 1.3 does match up with being 1.15 or greater, but my 50 degrees Celsius rise is too high. I have to go to the 115%. Okay. If it doesn't tell me anything, if my nameplate does not give me temperature rise and it does not give me service factor, it falls under all other motors at 115%. Okay. And again, this specific table right here is when starting current is not a problem. The next question we're going to address, starting current is going to be a problem. So speaking of the question, let's tackle the question. Determine the maximum overload protection using overload relays for a 25 horsepower, 240 volt, 3-phase continuous duty motor with a motor nameplate full load current rating of 65 amps, a temperature rise of 40 degrees Celsius, and a service factor of 1.15. So I'm going to bust out my trusty calculator, and I'm on this table. I really don't need to go anywhere. I don't need to go to 430.248 or 250. This is a 3-phase motor, so that would be 430.250. I don't need to go there because I'm not using table amps. I'm using nameplate. So my nameplate amps is 65 amps. And I'm going to multiply that by a value of, let's see, do I have a service factor? First of all, is starting current a problem? The answer is no. So I stay on this table. Now, is my service factor 1.15 or greater? Yep, says I got a service factor of 1.15. Now, the next one, do I have a temperature rise of 40 degrees or less? Yep. So I can use 125%, so that's exactly what I'm going to do. Multiply it by 1.25. There's my answer, 81.25 amps. It is that simple. Good. So we're going to move on. And when we move on, we are going to come to this question here. This one says, determine the maximum overload protection using overload relays when starting current is a problem. So when I see that when starting current is a problem, this is on the same page of your 2017 code book. We just go over to the right hand column and go down a little bit. And you will see it actually lists it up here where the sensing element or setting or sizing of the overload device selected in accordance with 430.21a1 and b1 is not sufficient to start the motor or carry the load. Higher size sensing elements need to be determined, not to exceed the following percentage. You'll see that the parameters are the same. Service factor of 1.15 or greater, temperature rise of 40 degrees or less. So the parameters remain the same. The only thing is going to be, you'll notice that I don't have 125 and 115% anymore. I've got 140 and 130. Okay, so that's my starting current as a problem table. So now I can punch up my trusty calculator. And it says that I've got a 50 horse, 208 volt continuous duty motor nameplate full load current rating 148 amps. So I'm going to hit 148 amps and I'm going to multiply that by, okay, it only gives me a service factor. It doesn't tell me anything about my temperature rise. But since I have a service factor of 1.15 or greater, even though it doesn't tell me anything about my temperature rise, I can now use 140%. So I'm going to multiply that by 140%. And there it is. I got to use overloads that are rated for 207.2 amps. Easy peasy. Awesome. That's not what I meant to do. All right, moving forth. Determine the maximum overload protection by using separate overload protection device to protect a 20 horse, 460 volt, 3-phase continuous duty motor. Realistically, everything that's up there doesn't mean jack. Here's the meat and potatoes down here, because it doesn't say anything about starting current's a problem up here. So all this stuff up here, I don't even really care about it. I've got a temperature rise of 50 degrees, a motor nameplate full load current rating of 13 amps. So the first thing I have to ask myself in these is starting current a problem? I didn't see anything in the question that said that starting current was a problem. Okay. So since starting current is not a problem according to this question, I've got to come back over to the table on the left. And there it is. So I can start off with my nameplate amps, of 13. And I'm going to multiply that by, let's see, I've got a temperature rise of 50. Well, that's over 40. So since my temperature rise is over 40, I have to go into my 115%. It wouldn't even matter. It's not listed what my service factor is, but even if it was listed, it wouldn't matter. Because my temperature rise is over 40, I'm already in the 115% parameter. And again, there we go, 14.95 amps. Out in the field, Square D has them. You'll have a table now that you'll go find that 14.95 amps and you'll match that up and you'll see what size heater you need or overload protection. Okay, we're gonna do one more of the easy peasy examples, and then the last one's not gonna be too hard either, but it's just asking for a fuse size, I believe. All right, so determine the maximum overload protection. Oh, here we go. When starting current's a problem, so we really don't even need to go. We need to get over here and find that table first. Starting current's a problem with our overload protection. And here we are. So we're gonna scroll up from there. All this is fluff, don't care. Marked with a temperature rise of 50 degrees. So 50 degrees, I'm already over my 40 degrees, so I know I'm going to use my 130% of 13 amps. Looks like it's the same motor. So 130% now of 13 amps, and now that's going to put me at 16.9. Again, these are pretty easy calculations. They shouldn't be too challenging to get into. The one thing they have to make sure is they are talking about thermal overloads on these ones. And when you come over here, there's also something under the thermal protector line. There are going to be thermal protector questions. Just make sure you're answering the right question. Okay, last but not least. Sorry, I made a mess of that one. All right, what is the maximum size? Now this one here, they're saying we're going to use a time delay fuse for our overload protection. Okay, so that's where it could get a little bit dicey-er, but we're still going to use the same stuff. Okay, so we're not going to change anything. So what is the maximum size time delay fuse permitted to be used for the overload protection for a 5 horse 2? The thing I want to find out first is whether or not starting current's a problem. So let's look for that. 5 horse 240 volt single phase motor, nameplate rating, service factor, temperature rise. Starting current, when starting current is a problem. So I'm going to go to my starting current is a problem table. And there's my starting current is a problem table. Now I'm going to find out, let's see, I've got a service factor of 1.15. I've got a temperature rise of 40 degrees. So that says, according to this table, that I can use 140%. 140% of my nameplate of 30. So 140% nameplate of 30. 140% nameplate of 30 is going to give me a value of 42. Well, we know that that on table 240.6a, my standard size of circuit breakers and fuses, I don't have a 42. So the question is, do I go down to 40 or do I go up to 45? So let's see what the code says. Provided the trip current of the overload device does not exceed the following percentage. So does not exceed means I can't go up to 45. That means I have to round down to a 40 amp breaker. Okay, so I'm still doing the same calculations. I just have to round down if I'm going to use a fuse or a circuit breaker. Hope you guys found this one entertaining, and good luck.